Scientists have discovered something that shouldn't exist, not according to our current understanding of the universe, not according to decades of astronomical research, and not according to the models that explain how black holes are supposed to form. When the James Webb Space Telescope began looking deeper into space than ever before, astronomers expected answers. Instead, they found a mystery: massive black holes appearing in the early universe, black holes so large that they seem to have formed far too quickly. According to traditional theories, there simply wasn't enough time. Yet there they were, lurking in the darkness of the young universe. And the deeper scientists look, the stranger the mystery becomes. Some researchers now believe our understanding of black holes may be incomplete. Others think we may be missing an entire chapter of cosmic history. And a few scientists are asking an even more disturbing question: what if the first black holes were born in a way we've never considered before? Today, we're exploring one of the greatest mysteries uncovered by the James Webb Space Telescope, a discovery that could change what we know about black holes, galaxies, and the origins of the universe itself. Let's begin. The James Webb Space Telescope is often described as a time machine, not because it travels through time, but because it allows us to see the universe as it existed billions of years ago. Every beam of light collected by Webb has traveled immense distances across space. Some of that light began its journey long before Earth even existed. When astronomers point Webb toward the most distant regions of space, they are effectively looking back toward the beginning of cosmic history. This is where scientists expected to find young galaxies, small galaxies, primitive galaxies, the cosmic building blocks that would eventually evolve into the massive structures we see today. Instead, Webb discovered something unexpected. Some of those ancient galaxies appeared surprisingly large, surprisingly bright, and hidden within many of them were signs of enormous black holes. The problem? Those black holes shouldn't have had enough time to become so massive. And that's where the mystery begins. To understand why scientists are puzzled, we need to understand how black holes are thought to grow. The traditional story begins with stars. Massive stars spend millions of years burning through their fuel. Eventually, they run out of energy. Gravity wins, the star collapses. If enough mass remains, a black hole is born. These newborn black holes are relatively small, usually only a few times more massive than our sun. Over millions and billions of years, they grow. They consume gas. They consume dust. Sometimes they consume entire stars. They merge with other black holes. Slowly, they become larger and larger. Eventually, some evolve into supermassive black holes. These giants sit at the centers of galaxies. The black hole at the center of our Milky Way contains roughly 4 million times the mass of our sun. Others are billions of times larger. The key word is slowly. According to standard models, creating a supermassive black hole takes a very long time, far longer than the age of the young universe Webb was observing. Yet Webb was finding evidence of enormous black holes that already existed when the universe was still in its infancy. Something didn't add up. As the first James Webb observations arrived, researchers around the world began examining ancient galaxies. Several teams noticed something unusual. Some galaxies appeared far brighter than expected. Others appeared much more developed than theories predicted. When astronomers analyzed the data, they discovered that many of these galaxies were likely hosting rapidly growing black holes, not small black holes, huge ones. Some estimates suggested masses reaching hundreds of millions of suns, and they existed less than 1 billion years after the Big Bang. To scientists, this was like discovering a fully grown city in a place where only the first villages should exist. The timeline didn't work. Either these black holes had grown at impossible speeds, or they had formed through a completely different process. The discovery triggered one of the biggest debates in modern astronomy. If black holes can appear this early, what else might we be wrong about? One possible explanation is that some black holes skipped the normal growth process entirely. Instead of forming from dying stars, they may have been born enormous. Scientists call these direct collapse black holes. According to this theory, giant clouds of gas in the early universe collapsed directly into black holes. No stars, no supernova explosions, just gravity crushing vast amounts of matter into a single object. If this happened, the resulting black holes could start their lives thousands or even hundreds of thousands of times larger than normal stellar black holes. That would solve part of the mystery, but it creates another question. Why don't we see evidence of this process happening today? And if direct collapse black holes existed, how common were they? No one knows. Some researchers have proposed an even stranger idea. What if black holes existed before the first stars? These hypothetical objects are known as primordial black holes. According to some theories, tiny fluctuations in the moments after the Big Bang may have created black holes directly from the energy of the early universe. If primordial black holes exist, they would be among the oldest objects in existence, older than stars, possibly older than everything we can see in the night sky, and they may have acted as seeds around which galaxies eventually formed. It's a fascinating idea. But so far, scientists have not found definitive proof. Still, the possibility remains on the table, and Webb's observations have given researchers new reasons to investigate it. The James Webb Space Telescope was built to answer questions about the early universe. Instead, it has uncovered new mysteries. Some of the earliest black holes ever observed appear far larger than expected, far older than expected, and far more difficult to explain than anyone anticipated. Maybe these black holes grew faster than our models predict. Maybe they formed through direct collapse. Maybe primordial black holes really do exist. Or perhaps the true explanation is something no one has thought of yet. What makes this discovery so exciting is that we are witnessing science in real time. The answers have not been written, the mystery has not been solved. Every new observation from James Webb could bring us closer to understanding how the first black holes formed, or reveal something even stranger. Because somewhere in the darkness of the early universe, hidden among the first galaxies, lies a secret that scientists are only beginning to uncover. And that secret may change our understanding of the cosmos forever. One of the biggest questions facing astronomers today is simple. How did these black holes become so massive so quickly? Scientists know that black holes grow by feeding. They consume surrounding gas. They absorb dust. They occasionally swallow stars. The more matter they consume, the larger they become. But there is a limit. A black hole cannot simply eat everything around it at unlimited speed. As matter falls toward a black hole, it heats up dramatically. This creates intense radiation. That radiation pushes material away. In a sense, the black hole begins fighting against its own food supply. Astronomers call this the Eddington limit. For decades, researchers believed this limit controlled how quickly black holes could grow. Yet some of Webb's discoveries seem to challenge this idea. Some black holes appear so massive that they would have needed to grow at nearly maximum speed from the moment they were born. And in some cases, even that might not be enough. This has led scientists to consider a radical possibility. Perhaps some black holes can temporarily exceed the Eddington limit. Perhaps under special conditions, they can consume matter far faster than expected. If true, black holes in the early universe may have experienced growth spurts unlike anything we see today. And that would completely change our understanding of how the first galaxies evolved. The earliest universe was a very different place. There were no planets, no solar systems, no Earth, only vast clouds of hydrogen and helium left behind by the Big Bang. Gravity slowly pulled these clouds together. The first stars ignited. The first galaxies began to emerge. But what if black holes were among the very first structures to form? Some researchers believe black holes may have played a much larger role in shaping the universe than previously thought. Instead of galaxies creating black holes, black holes may have helped create galaxies. The idea sounds backwards, yet it could explain several mysteries. A giant black hole exerts enormous gravitational influence. Gas naturally falls toward it. As matter accumulates, stars begin to form. Over time, an entire galaxy can emerge around the black hole. If this theory is correct, then supermassive black holes were not merely passengers in galactic evolution. They were drivers, the architects of the cosmic structures we see today. And Webb may be providing the first evidence that this process began far earlier than anyone expected. Every galaxy contains something mysterious, something invisible, something scientists still do not fully understand. Dark matter. Although dark matter cannot be seen directly, its gravity affects everything around it. In fact, dark matter makes up most of the matter in the universe. Without it, galaxies would not exist as they do today, because dark matter remains one of the greatest unsolved mysteries in physics. Some researchers have wondered whether it could be connected to black holes. Could dark matter have accelerated black hole growth? Could dark matter have helped giant black holes form unusually early? Some theories even suggest that certain black holes could themselves be related to dark matter. At the moment, there is no definitive answer. But every time Webb discovers another unexpectedly massive black hole, the dark matter question becomes harder to ignore. The universe may be hiding a connection between two of its greatest mysteries. And if that connection exists, it could transform modern physics. Science advances by making predictions. When observations match those predictions, confidence grows. But when observations repeatedly contradict expectations, scientists must investigate. This is exactly what is happening today. For years, computer simulations suggested that galaxy formation followed a particular path. Small structures formed first. Large structures appeared later. Everything grew gradually over time. Webb has challenged that picture. The telescope continues to reveal galaxies that appear more developed than expected, more massive than expected, and black holes that appear older than expected. This does not mean scientists were wrong about everything. Far from it. Many theories remain successful, but it does suggest that some important ingredients may be missing from the story. The universe might be more efficient at building structures than we thought. Or there may be physical processes operating in the early universe that we have yet to discover. History has shown that some of the greatest breakthroughs in science occur when observations and Webb may be delivering exactly that kind of moment. The story is far from over. In many ways, it has only begun. The James Webb Space Telescope continues to observe distant galaxies every year. Each observation provides new clues, new puzzles, and sometimes new surprises. Future telescopes will add even more information. Scientists hope to observe galaxies closer to the dawn of cosmic history. They hope to identify the earliest black hole seeds and perhaps witness how the first supermassive black holes emerged. Some researchers believe the mystery could be solved within the next decade. Others think it may take generations. The truth is that nobody knows. What everyone agrees on is this: the universe still holds secrets, and some of those secrets are far stranger than we ever imagined. For centuries, humans have looked toward the night sky searching for answers. Every generation believed it understood a little more than the one before. Yet every great discovery has revealed something unexpected. The James Webb Space Telescope is no exception. What it found in the early universe has forced scientists to ask difficult questions. Questions about black holes, questions about galaxies, questions about the origins of cosmic structure itself. Somewhere in the darkness of the ancient universe, the first giant black holes emerged. We still don't know exactly how. We still don't know exactly when, but one thing is certain: the mystery is real, and the answer could change our understanding of the universe forever.